Good morning, everyone.
Good morning.
Morning.
All right, it's 9 o'clock. So a few administrative things before we start. On your homework assignments, I've just changed a setting on those where if you, for some reason, can't get the assignment done in time, you'll be allowed to work on the assignment past the due date, but there will be a 20% penalty on anything you haven't done. So let's say there's 10 problems and you finish 7 of them on time, then the remaining 3 problems you can finish, but you'll get a 20% deduction on each of those problems once you submit it, all right? And that's just to give you an opportunity. So I'm not sitting here having to deal with people saying, oh, I had to work, or back and forth emails. You're allowed to work after the due date, but you just can't get 100 anymore on the problems you haven't done. Okay, so I just applied that setting, and I thought we would look at real quick, just kind of the first assignment was due, I think right now. I think it was due at 9 a.m. I have to go back and check, but this is kind of hard to read, but this is like a scatter plot of all the students, and it shows their grade here, how much time they spent on the assignment. And so you can see that 11 students on this first assignment had scores between 0 and 69, 3 were between 70 and 89, 7 were between 90 and 100, and then I had 3 people who didn't submit anything at all. So just to give you an idea of what I see on my end, and then I can go in and look at each student if I want to, okay? Make sense? So there's a few of you here that well, I don't know if you're here, but I haven't looked to see who these 3 people are yet. And then there's some students that struggled with this first assignment. So anyway, that's it. I just want to talk about it. Any questions or comments or anything?
Was that for the assignment like the 12.5, or was that the Dropbox bonus assignment?
That was the 12.5.
Okay.
The Dropbox was a bonus, and I sent an email out after having a discussion with several students about the bonus problem I had given you originally. That, well, just check your email and you'll get it. But let me see, I can check to see who's submitted. I know I've had at least 1 submission. Maddie, do you mind if I show yours?
Sure.
Okay, so I know Maddie turned hers in, and so we'll look at it just to show you this is what I was hoping to see. Remember, the main idea of this bonus was to give you an opportunity to send me a PDF file, a single file that has multiple pages on it. So Maddie sent me this. It's a single file. I click on it, and she just put a cover page, and then here's her work. So it's 2 pages, but sent as a single file. That's exactly what I'm looking for. Cameron, can I look at yours?
Yeah, you can look at mine.
Okay, so again, this is just to see, okay, good, perfect. Cover page, here's the, okay, so multiple pages, that's exactly what I want. And I can read it. And the reason why I do this, just so you know, the reason why I do it this way is that, and really you don't need to know this, what I do is once everyone's submitted everything, what I do is I select all the files, and then I download those, save them, and then I open up my OneNote, and then all I have to do is insert. Let's see here. Oops. Sorry, just give me a second. There's really no need for me to be showing you this, but okay, here we go. So what I'll do is I'll just grab Maddie's and I'll just drop it in here like this. And it takes a second, but it's going to bring it in here. And then once it's here, I can easily write on it and grade it and then send it right back to Maddie. So it's just super easy when it's 1 file. If you send me 10 pages, I have to import each page, and then imagine that times 20 something students. times 5 classes, it just becomes a nightmare for me. So anyway, please, one file. Any questions on that? Anything else before I begin? Okay, we are going to talk about circles today. So this is the last, I would say this, okay, the previous section I would agree was very tedious. Like I said, you had to be very meticulous, make sure you're not messing up signs. We are going to completely put that away. Okay, so partial fraction decomposition, we pack it up, put it in a nice little box, wrap it up. We'll take it out again in Cal 2. Okay, you're not going to see that. Well, you'll see it on the test, but I'm just saying that concept we do not need for the rest of the semester. All right. Circles is another one of those concepts that's going to come up. It'll come up here in pre-cal, but really the ideas here are you're going to see later on in Calculus 1 and Calculus 2. So this is our last section before we really start getting into like the pre-cal, the chapter 7, I believe. Yeah, so this is our last section here, 2, 4, and then we start chapter 7 where we start getting into the real trigonometry stuff. All right, and we'll spend the rest of, well, almost all of February in chapter 7. All right, so here we go, circles. So before we start with circles, there's 2 concepts that we have to make sure everyone here knows how to do. And if you can do those, then we can do the rest of the section. So the first concept here is finding the distance between 2 points. So in college algebra, I know for a fact you should have seen this, that if you're given 2 points, we call it the first point x1, y1, and the second point x2, y2, then we can always find the distance between these two by using this formula. Now, did I send you all the formulas? Something tells me I forgot to do that. I'm going to check real quick.
I don't remember receiving anything.
I wouldn't have sent them. I would have put them in the files. Let me see here. Let me just double check. I don't think I don't know. Okay, so if you go into our course and you go into files, yeah, I didn't put it there yet. So I will put it in here. Let me see if I have it. I can just drop it in here real quick.
There is a file section from January 20th. Was that the old formula sheet?
January 20th. Was this it? Yeah, I think that's the old one. I think that's the old one.
Okay.
Yeah, I'll get it in there. I'll do that today. But I'm going to give you, remember I told you I was going to give you the formulas from the calculus book, which does have this distance formula on it. Okay. But here it is. Here's the formula. So all you do is you take the difference of the x coordinates, square them. You take difference of the y coordinates, square them, add those together, and then take the square root. And that will always give you the distance. Does anyone know where this formula comes from? Like how we would generate that formula on our own if we wanted to? It's a pretty simple construction once you see it. All you do is you create a right triangle here. And then we use the Pythagorean theorem. Remember, Pythagorean theorem says if this is A and this is B and this is C, that we have A squared plus B squared is C squared. Right? Does that ring a bell? I hope that rings a bell. So what we do is we look at this and we say, okay, well, what's this side? This side is just the difference in the x coordinates. You know, as you go from this point to this point, the x coordinates change by a certain amount. So you just take the difference of the x coordinates. And then if you want to know this distance here, well, that's the difference of the y coordinates, right? You move up. So that's like your rise. That's y2 minus y1. So this is kind of like rise over run, but so now this is kind of like the A, and this right here is the B. So if you take this and square it and you add to it this squared, that's this right here. That would give you C squared, but we want C, so you would take the square root on both sides. So that's where it comes from, right? all you have to do is know how to use it, all right? And we'll have to use it today. So, all right. Now, the next concept that we need to be clear on is completing of the square. And I know that you see this in college algebra, and I know that some of you feel very comfortable with completing the square, but I have a challenge here for you that might throw a twist into things. And I'm only saying this because in all my years of teaching calculus, most students come in to calculus and they know how to complete the square, but the problem is the way they're taught, there's a problem with it, okay? So I want to make sure everyone understands completing the square the way I'm going to show it to you, because you're going to need this way when you get to Cal 2. Okay, so completing the square. So what is completing the square? You start off with the quadratic expression, okay? Ax squared plus bx plus c. And we need to figure out a way to convert that to this form, a times x minus h squared plus k. So to do that, that's what completing the square is, all right? So for example, this quadratic, 3x squared minus 12x plus 16, can be converted to this. My question is how? So now I get to ask you for help, and let's see if we can catch the new thing here today. Okay, like if you know completing the square, there's something new, and let's see if we can just kind of stumble upon it. So I'm going to write this down, and I'm going to ask anybody in the class to volunteer to tell me how, like what the steps are for completing the square. So does anyone remember the first step to complete the square?
Divide b by 2 and square it.
Divide b by 2. So you're talking about the number in front of x,
Yes.
right? You're going to take that number, divide by 2, and square it. So Maddie is slightly correct. There's a step before that.
Factor out the 3.
Okay, you have to have a coefficient of 1 on x squared before you can do anything else. So when you're looking at this quadratic, we have to focus our attention on the number in front of x. And in this case, it's a 3. To complete the square, it has to be a 1. So someone said factor out a 3. I didn't see who you were, but that is correct. So everyone, I'm going to factor a 3 out. Okay. And you have to factor a 3 from every term. Wait a minute. Are we going to run into a problem here? I can factor a 3 out here. I can pull a 3 from the 12. That becomes 4, right? But does 3 go into 16?
No.
So I can't factor, well, I can factor a 3 out. So this is, again, this might be something new. This is going to be 16 over 3. Now that may seem weird to you, but it is true. So just check. If you multiply this 3 through, you get this. 3 times -4 gives you 12. And then when you move this 3 and hit that, the 3's cancel and you're left with 16. The point is you can always factor a number out of another number, even if it doesn't go in there evenly, by creating a fraction. We'll get another example of this in a minute. Any questions on that? Okay, now the next step, this is where Maddie suggested that what we do is we look at the number in front of x, okay, which in this case is -4. And Maddie, what did you say we do with that?
Divide by 2, then square.
Okay, so we're going to divide this by 2 first, okay? You always divide that number by 2, always. Okay, so let's write that down. -4 divided by 2 is -2. I'm going to box this. I'm going to put a star next to it. That's my first like magic number. Okay, I'm going to use that number again in a minute. And then Maddie said we take that answer and we square it. So I'm going to take that number -2 and I'm going to square it. And that becomes 4, +4. And I'm going to put a double star next to that one because I'm going to need that one in a second. So I have two magic numbers that are created through completing the square. Okay, here's the critical step. This is the part that most students learn a certain way. And I want you to erase that from your brain because, well, you'll see. Okay, so can anyone tell me what the next step is? I took the number in front of x, I divided by 2, I squared it. Okay, now what? Anyone know? I've made you nervous to answer now because I've made you think you might be wrong. We're supposed to do something with this number 4.
You have to add it to the minus 4x.
You have to add it to the minus 4x. So how many of you remember learning that at this point, you're supposed to take this 4 and add it on both sides of the equation? Does that
Right,
sound
I
familiar?
remember doing it like that.
What's that? Does that sound familiar?
Yeah, that sounds
Take the
familiar.
4, you
Yes.
add it to both sides of the equation. Here's the problem. We don't have an equation. This is not an equation. This is an expression. So in college algebra, most of the time what you're doing is you're taking 3x squared minus 12x plus 16. And in college algebra, you're probably trying to find the x-intercepts of this parabola. So you're setting it equal to 0. And that's what you're doing in college algebra. So you have an equation, so you could add the 4 to both sides. But it's because you have an equation. We are not trying to solve an equation here. All we're trying to do is rewrite an expression. So it is impossible for us to add 4 to both sides of an equation that doesn't exist. Does that make sense?
Yes.
Yes.
Okay, so here's what we do instead. And this is so critical because this is probably one of the first times you've ever seen this. I want you to agree or disagree with me on this. Do you all agree that I'm rewriting the expression we just had? Does everyone agree that there's a 0, plus 0, right next to that? So like right after this minus 4x, I could say there's a plus 0 here, right? I could say that?
Yes.
It's not wrong, right? Now, what I'm going to do is I'm going to rewrite that 0 in a very clever way. So watch, I'm going to go 3 parentheses x squared minus 4x. Now here, instead of writing 0, I'm going to write plus 4 minus 4. Do you all still agree that's 0? Yes.
Yes.
Now I used 4 because our answer here was 4. Okay, so that number will go here, and then you just subtract it. And then you still have the plus 16 over 3. Let me check something. Something seems...
Are we doing this so no matter what, it will it will just cancel out to 0?
We're doing this because, well, because there is a 0 here, right? We call this a hidden 0, all right? It's a hidden 0. It's there, right? But by rewriting that 0 as 4 minus 4, instead, what we're going to gain from this is the next step. I need to copy this and take it to the next page. Okay, so here's what we're going to gain. These 3 terms, those 3 terms are guaranteed to factor as what we call a perfect square trinomial, or that is a perfect square trinomial. So that means that what I have there written should factor to be something squared. Okay, can anyone tell me what it is? Something squared, what is it?
X minus 2 squared.
X minus 2 squared, that's what it is. Now, if you don't believe that, just do x minus 2 times x minus 2 and do your FOIL, and you will get x squared minus 4x plus 4. So this step of realizing this hidden 0 and then adding and subtracting that number, that magic number, will guarantee that these 3 will factor into, or that it is a perfect square trinomial. Now, here's what we can do. Write down the 3. Let's do parentheses. These 3 right here. Do you remember we had a magic number up here? Remember our first magic number? This is where I can use that first magic number. If I just write down x and then that magic number minus 2 squared, that's how, you could think through this and get it this way, or you could just use the magic number and just be guaranteed that this is what it'll look like. X, take away 2, and then square that. That's the first 3 terms. What do I still have over here?
The -4 and the plus 16
the
over 3.
I
16
still
over
have
3.
those, right? So I still have minus 4 plus 16 over 3. Yes?
Yes.
All
Yes, sir.
right. Now, the next thing I'm going to do is I'm going to go ahead and put these two together. Okay, so I'm going to take -4. I'm going to add 16/3, which means I have to look at -4 as a fraction, multiply top and bottom by 3. So I'm getting a common denominator so I can put these together. And that's just going to give me 4/3. So here's where I am. 3, and then I have x minus 2 squared, and then I have plus 4/3, like that. Okay, that's just me putting those two together. And now last step, I'm going to distribute the 3 through. And when I multiply the 3 times this first part, you are not allowed to push that 3 inside the parentheses. You can't do that because of the exponent. Order of operations says you would have to do the expansion of this before the 3 went through. So I just leave the 3 out front. But when I do the 3 onto the second piece, the 3 and the 3 here cancel, so I'm just left with +4. And we have now completed the square. All right.
So
there's go ahead.
the x minus 2 squared, will you always be able to utilize the first number from dividing the number in front of x by 2? Would that be a short, is that consistent or okay?
Yes, it's consistent. That's why I said that we're going to get 2 important numbers. The second number is the one you're going to add and subtract. The first number is going to be the one that goes into the parentheses with the x. Every time, guaranteed. So just a real quick recap. If you're going to complete the square of a quadratic, you must make sure the coefficient here is a 1, so you have to factor out whatever number that is. Then you take this number here, take half of it, then you square it. You realize a hidden 0, you add, subtract. First 3, perfect square trinomial. Figure out what this number is, distribute your number back through, and you're done.
So we'll always look for those like magic numbers, like you said, and like put them to the corner.
Yep. Well, I always do. That's what I do. I mean,
Can you go over that step one more time?
well,
Like,
I actually have another couple of examples.
oh, okay, thank you.
Yeah. So give me a second. I turned up the heater in here. It's really hot in this room. Hold on. Go ahead and start the first one. The first one's an easy one. All right. So start the first one. Do we have to factor anything out on the first one?
No.
No, sir.
No. Okay, so we just take the number in front of x, right? Which is +4. Take that, divide it by 2. Gives us 2. That's our first. I don't know why I call it a magic number. It's really, there's no magic here. Okay. We're going to square that 2 and get 4. That's our second one. And now let's call on somebody. Let's start out today with Isa. Is Isa here? Am I saying that right? Another class, yeah. I don't think we have Isa with us today. All right, how about Leslie?
I'm here.
Okay, so Leslie, I want to rewrite this. So now that we went through that last example, what would I write? What would you write down here now?
So now that we have the
This is where we see the hidden 0, right? Right behind this 4x is a +0.
so then we would write yeah. X
Right,
squared.
no, it's all right. We're just gonna rewrite everything that's here, the first two terms. But now, what am I gonna use for zero though? I'm not gonna put zero, I'm gonna put plus something, minus something.
The 4.
Okay, so +4, -4. Now, everybody, it has to be +4, -4. It can't be -4, +4. You don't get to choose the order. It has to be the plus, then the minus. And then don't forget, Leslie, we also have the -5 there, right?
Yes.
Okay. Now, Joshua, because you asked me, right? Joshua asked me the question. Joshua, what would the first three terms turn into?
That would turn into x plus 2 squared.
X plus 2, and the plus 2 is coming from that 2 right there. So x plus 2 and then squared. And then go ahead and finish it off, Joshua. What do we still have over here?
So we have -4 minus 5, which is get us -9.
-9. There you go. And that's it. We're done. We have completed the square. Remember, to complete the square means that you should end up with something that looks like this. It should be a number in front of a parentheses with x minus a number. Now, it's okay that this is a plus and this is a minus, because you could look at that plus as you could look at it as minus -2. Okay, so that's okay that it's a plus there. But basically it's x with a number inside a parentheses squared, and then you have some number on the outside. Okay, as long as you get it to that form, we have completed the square.
So as long in the equation is we have one minus and one plus sign, we're okay. It doesn't matter the order.
Where? Oh, you
Just
mean here?
Yeah, just how you said, like how the plus is first. As long as we have both in that equation, it should be fine.
As long as you have two numbers, they could both be pluses, they could both be minuses. Doesn't even matter.
Okay,
It's
so
more of like, don't focus your attention so much on the sign here and the sign here. Just the fact that you have x either plus or minus a number squared, and then plus or minus a number.
and as long
It's
as it
more
follows
the
that form, okay.
Yeah, it's more the form of the quadratic with a number in front and a number by itself. That right here in college algebra is called the standard form of a quadratic. So that's really what we're trying to do, is get it to its standard form. All right, so let's look at B. All right, for B is a little bit different. What's different about B?
-3 isn't divisible by 2.
Yeah, so -3, when we divide it by 2, so we don't have, there's a 1 in front, we don't have to take anything out, right? So we don't have to factor anything out. So we go automatically to the -3. And when we divide it by 2, well, unfortunately, that's not a nice number, right? And we're not going to use decimals. We're just going to leave it as that. That's our first magic number. -3/2. And then we're going to square it. So when we take -3 over 2 and square it, we get 9/4. Square the top, square the bottom. And now we're going to take this, write the first two terms out. And then Tyler, we're doing what now?
Sorry. We're just gonna rewrite the 0, so it'll be x squared minus 3x plus 9/4 minus 9/4 plus 1.
Perfect. There we go. Good job, Tyler. Now, Tyler, let me ask you while I've got you here. What can you tell me those first three are going to turn into?
X minus 3/2 squared.
That's it. Okay, so see how we're doing that? We're using the x, we're using that number squared. Okay, we're done. And then we still have to do this. Now, Tyler, you're off the hook. I'll just do this over here on the side, -9/4. Plus 1 is same as +4/4, so that gives you -5/4. I'm trusting everyone here can add fractions. Okay, so there we go. There's the completing of the square. And we have one last one. So, Angelique.
Yes,
Okay, how's it going?
it's going good.
Good. Okay, so what would be our first step here, Angelique?
You would factor the 2 out.
Okay, so if I pull a 2 out, I would get x squared. Are you comfortable with what would come next, Angelique?
Yeah.
What is it?
Negative 5 over 2
Very good. And then,
and negative 3 over 2.
okay, good. So if the number can't come out evenly, all you do is you just put that number on the bottom of these. And just think about what would happen if you distribute back through. The 2's would cancel and you get the 5 and the 3. All right, good. So next is Allison. What are we doing, Allison?
You would be, would it be 2x squared? You would put the 0 in, but then you would like substitute it with like the magic number.
Okay, so what is it? We don't have that magic number yet. So how are we going to get it?
We're gonna divide 5 seconds by 2.
Yeah, this one's going to be tricky.
Negative
Remember,
5 seconds.
we have to take that and divide it by 2, right?
That's
That's
the
what we're
same as
supposed to
just multiplying by half, right?
That's right. So to take this, and now this is going to look ridiculous, but I think this is an easy way to look at it. If we're going to take that and divide it by 2, I hate using that division symbol because it makes you think you're back in elementary school. But dividing by 2 is the same as multiplying by the reciprocal, and the reciprocal of 2 is 1/2. So you wind up getting negative 5/4. Another way of looking at that, if you don't like that, taking 5/2 and dividing by 2 is the same as dividing by 2 over 1. And then again, division of 2 fractions turns into multiplication of the reciprocal. And if you do it that way, you still get negative 5/4. Okay, that's our first magic number. Our second magic number, we have to take that and square it. So we get 25/16, we square both. And Allison, that's the thing we're going to add and subtract, right?
Yes.
Okay, so I'm going to start writing this thing down. 2x squared minus 5/2 x. I'm going to add 25/16, and I'm going to subtract 25/16. And then I still have minus 3/2 over there. All right, Lawrence, are you there?
Yeah.
Yes?
Yes, sir.
You doing all right today?
Mm-hmm.
Okay. So Lawrence, what I want you to do is, I'll take care of the first part. I want you to go work on this on the side and see if you can't put those 2 together. That way, when I get to it, you'll be ready to go. See if you can.
Okay.
And I'm going to ask somebody else the next part. So I've got 2 here. I've got parentheses. Now these 3 terms are going to go together. And James, what would they become? What would the stuff in yellow become?
It would become x minus 5/2 square.
5/4. Remember?
Oh,
yeah.
yes, sir. 5/4 square.
There we go. Good. Now, Lawrence might still be working on his over here, so I'm going to write it down just so we're all familiar with what we're trying to do. We're trying to put the blue stuff together.
I have a question. Yes, sir. If we have a magic number and we can reduce it, would we always want to reduce it if we could?
If it's reducible, yeah. Mm-hmm.
Okay.
Yeah. These weren't reducible though.
Oh, yes, sir. I was just asking,
Yeah,
like, just in case. Yeah.
Yeah. Reduce your fractions.
Thank you.
Lawrence, did you get it?
Is it -2 over?
Hold on. Let's see. Oh, what did I do? Multiply top and bottom by 8. Why did I do that? Okay, I put 16 here. What is that? 49.
I got -49/16.
Yeah, I think you should get -49 over
Oh,
6.
yeah, I did the math wrong.
Did you miss something? Okay.
Yeah, I added it wrong.
That's okay. I mean, that's why we're doing it here. We will always want to try and make mistakes now. We want to make mistakes on the homework. And then when it comes to the test, we want to have gotten all those like mistakes out of the way. All right, we're almost done. Almost done. We got to pass the 2 back through. So the 2 is going to go here. And then this 2, when I pass this 2 through, I'm going to just stick it over here like this, 2, it reduces out and that 16 becomes an 8. So we get minus 49 over 8.
Real quick, sir.
Yes,
Why didn't we reduce the 49 over 16 to negative 7/4?
where?
The 49 over 16. Why
49
didn't we
over
reduce that before
16.
we put it?
Oh, we didn't reduce this, is that what you're saying?
Yes, I'm just asking, should we? Why didn't we?
How does it reduce?
7/4.
7.
Like, wouldn't you take the square root out of each?
Oh, no, that's not reducing though. That's taking the square root of top and bottom, which there is no square root. So you can't just arbitrarily take square root of top and bottom. That won't reduce a fraction. Like, if you take the fraction 4/9, right? 4 over 9. That is not the same as the fraction 2 over 3. Because you're doing square root of top and bottom.
Oh, okay, I see.
You can reduce the fraction 4/8. That becomes 1/2. That is true because 4 goes into 4, 4 goes in there twice. I know what you're doing, but
Okay.
that's not reducing a fraction.
Okay, I see. Yeah.
Good question though. Those are little things we want to make sure we're clear on. All right, we're done. Okay, I think the hard part's over. I think the rest of the sections, now that we get into the material, as long as we can do this, we're good. Okay. So here we go. The main ideas of this section.
Yes, sir. Yeah, I like this section a lot better than our first section.
Oh yeah. Yeah, this section's a lot easier than the first section. In fact, I mean, we've spent 40 minutes on just the preliminary stuff because I know this part's gonna just take us probably 30, 35 minutes. Okay, so we're gonna talk about circles. So a circle is, I think, something we're all familiar with. It is the set, the formal definition is that a circle is a set of all points in the XY plane, that means on a sheet of paper, that are a fixed distance r from a fixed point. So if you fix a point somewhere on a piece of paper and then you fix a distance and draw all the dots that are that equal distance from that point, then you get a circle, all right? So the center, this is the center of the circle. We normally use HK to represent the center of the circle. Instead of XY, we'll put HK. And then the radius we label R. Okay, so we're all, I think we've all seen that or comfortable with that. So for these 4 examples, what we're gonna do is look at them. I want us to identify the center, and then I want to identify the radius. And I'm gonna call on people, all right? So here we go. So Young, are you with us today?
Yes.
Okay. So looking at this first one, make sure you kind of can understand how things are labeled first. Can you tell me what the center of that circle is? Can you tell from the picture?
No.
Okay. So when I ask for the center, I want you to give me a point. And the point has to be HK. So can you tell from this picture that this is the center point? Yes, of that circle? And
Yes.
what are the coordinates of that point?
2 and 1.
Yeah, 2, 1. So it goes out 2 and up 1, right? That's what that is. So the center of the circle is simply 2, 1. Okay. Now what we need is the radius. So I'm gonna stick with you. So Young, I'm gonna erase some of this. Can you tell from looking at this picture the distance from the center to any point on the outside? Can you tell what that distance is? I'll give you a hint. How about from here to here? Can you tell me how far that is? From there to there? Do you know the X coordinate of this point right here? What's the X coordinate?
0.
Okay. And what's the x coordinate of this point?
2.
2. So to go from this point to that point, you had to move 1, 2, right?
Mm-hmm.
But then that would correspond with the radius, wouldn't it? Because the way they draw it, here's the center, and then that point touches. And so that's telling us that the radius should be 2.
Yes.
Okay. So the radius here, I'm just gonna put R equals 2. All right, good. Next up is Michael Clark.
Yeah.
Okay, so on this next one, 10, can you tell the center?
It's 1, 2.
1, 2. So we write it as a point. Can you tell what the radius is?
I'm not sure.
Okay, Michael, do you agree that to get from this point down to this point, right, that's the radius?
Yeah.
Okay, can you tell how far we had to travel to get from one point to the other? That's a change in what, the X or the Y?
Y.
Y, okay, so can you tell by looking at these 2 points how much the Y changed?
Like 2.
2. So it's 2, right?
Wait, would it ever be like a -2 since we're going down?
Nope, because it's a radius, it's always a distance, and we always measure distance as positive number. But good question, good question. That make sense? It's like a tape measure. Okay, sorry, James' video froze up, so I wasn't sure if he was just still looking at me going, what? Okay. All right, number 11. Okay, let's see who's up here. We're gonna mix it up here. How about Sierra?
Hello.
Hello. This is a tricky one. Trickier, more tricky? More trickier. How about that?
So for the center, would it be 1, 3?
So 1, if you said 1, 3, that means I'm going to go to the right 1 and up 3.
Oh, sorry. Maybe 2. No, I don't know.
Okay, so let's talk about the x coordinate. Okay, this is the point we're talking about, right?
Mm-hmm.
Okay, so let's look at this first point. I'm going to highlight it in yellow. Can you tell me the x coordinate of that point?
That one's 1.
1. Okay. Now, this point in green, right, is going to have an x coordinate of 4, right? So that means the distance from this point to this point, what's that distance? If you went from 1 over to 4, what's that total distance?
Would that be 3?
3, okay. Now, 3 is the measurement all the way across the circle, which we call the diameter, right?
Mm-hmm.
So the radius is half of that. So go ahead. So can you just tell me what the radius is? Let me just tell me what the radius is, because we do know the radius right now.
So would it be 1.5?
1.5. I'm just going to leave it as a fraction now. I'm going to put 3 halves.
Okay.
Does everyone agree with that? That's just by saying, okay, look, the distance from here to here, that's 3, but then that's twice as much as what we need. So we take half of 3. Half of 3 is our radius. Now that does not solve the next part, the next kind of problem, which is, you know, what is the x coordinate, right? What is that x coordinate? So Sierra, if I start at 1, right, here's 1. How far do I have to move over to get to this point? You can tell me the decimal. Like if I start at 1, and then you said that this distance you said was 1.5, right?
Mm-hmm.
So where am I now?
So that would be 2.5?
2.5, right? That would be 2.5. That's the x coordinate of this point. Now, I personally don't like using decimals. I would rather say, okay, I started at 1, I added 3 halves, that's the radius. Put those together, 2 over 2 plus 3 over 2, that's 5 halves, which is 2.5. But I'm going to write as a fraction. If you put a decimal on a test, I'm not going to take off. All right, Sierra, you're almost off the hook. Can you tell me that's what H is. Can you tell me what K is? I'm going to have to erase some of this though. Well, maybe I won't. Can you tell me the Y value of that point?
Would it be 2?
It's just 2 because it's in line with the other 2 points. And both of those have a Y coordinate of 2. So there you go. Okay. We good? A little tricky, that one. All right, last one. Maddie, you're up. You get the fun one. You know what I'm going to do? I'm going to take this over and we're going to move it to below here so we can mess with it. All right, so they're giving us this point and this point. So Maddie, I'm going to let you kind of tell me what you want to do here.
The center would be 1, 2, right?
1, 2. Okay, so let's see, what's your reasoning here? This point has an X coordinate of 0. This point has an X coordinate of 2, right?
And those two constitute the diameter, and the center intersects the diameter at the halfway point. So if it's 2 units of the difference, the halfway point would be 1.
So you're very confident that this line goes through that center?
I believe so.
You think so? I don't know. I mean, this is something to be debated. Look, in the last problem, I have to erase all this. In the last problem, these 2 points had the same Y coordinate, didn't they?
Mm-hmm.
And because they have the same Y coordinate, I know that the line drawn through them must go through the center. It has to, right? Because they have the same Y coordinate. What I'm afraid of here is that if I give you a circle and I give you this point and I give you this point, then can you say with absolute certainty that if I connect a line through those, that it goes through the center?
No, you can't.
You can't say it in general. Now, if they have the same Y coordinate, yes. If I line these up straight across from one another, then yes, it must go through the center. If I line them up where they have the same X coordinate, then yes, it must go through the center. But if they're just kind of arbitrarily out there, it's not a guarantee. Does that make sense to everyone? That there's no guarantee here. So I'm a little bit hesitant to just say, okay, the X coordinate here is 0, the X coordinate here is 1, and so halfway means that has to be 1. Even though it looks like that's true, that's not necessarily guaranteed. You with me? All right, yeah, so you got the hard one, Maddie.
Would we plug it into the distance formula?
Okay, so we are going to use a distance formula, right? But the distance, so how would you like to use a distance formula?
What do you mean?
Well, you said if we plug into distance formula, then what distance are you trying, what are you going to find the distance between? These 2 points? Is that what
you'd want the diameter? That way you could at least get the radius. But if you're saying it might not be the diameter.
Yeah, that's the thing. It might not be the diameter. Why may it not be the diameter? Again, because there's nothing that's telling you these points are directly across from each other. It looks like they are.
You're not sure if you can draw a line straight through.
Yeah, and if we draw a line straight through, we don't know if the center is really here. It looks like it is, okay? I would argue that does look like it goes through the center. But there's not a certainty of that. So let's see. We need to think through this. The reason why I'm really taking my time on this is because I'm doing this problem for the first time right now. And I'm trying to figure out if there's a way we can do this, because right now I feel like they haven't given us enough information. I feel like this is a This is a problem that they put in the book that is actually a bad problem. Because I can't find the center. I can't find the center because I'm not sure, again, if these 2 points are directly across from one another. And I can't find the radius because I don't know what the center is. If I knew what the center was, right? If I knew what this point was, then all I'd have to do is find the distance between that point, and that would be my radius, right? But I need the center point. And I can't find the center point unless I'm absolutely sure of it. Do y'all understand what I'm saying?
Yes.
Yes, sir.
Okay. So I think that this is a bad problem. I think it's not correctly presented. So to save us, okay, and so that we can solve it, I'm going to add something to the picture that was not included. And that means I'm going to put a dotted line through there. And that means now that we can assume that that distance across is a diameter. And now we can follow more of a procedural thing of saying, okay, well, if that's the diameter, then what Maddie said, this has to be, what did you say it was?
1,2.
1,2. Does everyone see that? This x coordinate 0, this x coordinate's 2. So halfway between there would be 1. So you got 1, and then the y coordinate here is 1, the y coordinate here is 3. So halfway between that is 2. Now we can say that that's the center. And then the radius, how would you like to get the radius? And anyone, but Maddie, you can go or whatever.
The radius would equal 1.
Okay, and how are you getting that?
Simple math, subtract one x coordinate from another, or y coordinate.
You have to be careful though, because the x coordinates are.
You can't say that though, because it's going
this
diagonally.
one, right? Yeah, this distance is 1. I agree with that. From here to here is 1. And I agree from here to here is 1. But this hypotenuse is not necessarily 1. Does that make sense?
Yes.
So why don't you said the distance formula earlier. So why don't we do the distance between here and here? Because we know the center and we know one of the endpoints. So we can do that distance. Y'all agree?
Yes.
Okay, so that's what we'll do. I'll call it R. It should be the square root of, let's see, the difference. I'm going to do these 2 points. So I'm going to do the difference between the y coordinates. I'm going to go 3 minus 2 squared, plus now the difference between the x coordinates, 2 minus 1 squared. And this should be equal to the square root of 2. I'll let you get that yourself, but it should be root 2. The important thing to note is that I'm just finding the distance between 2 points. So I'm just applying the formula we had from earlier. So the center of this circle is 1, 2, and the radius is the square root of 2. Assuming that that dotted line goes through them, through the center. Sorry, Maddie, that was a tricky problem.
No problem.
Sometimes that's just the way the dice rolls. All right, can I move on?
Yes, sir. I have a question first.
Yeah.
So if we don't know exactly what the radius is, we would do the square root, kind of like we would do the y2 minus y1 square x.
Yeah, the idea is that if you have a circle and you know its center, okay, check, and you know any other point on that circle, check, then all you have to do is calculate that distance and you've got the radius.
Okay, and then that's where we would do the y2 minus y1.
Yes.
Okay.
Yeah, so when I say the distance, I mean this formula right here.
Wouldn't it be just quicker to use the Pythagorean theory?
It could be. It depends on the problem. I mean, it really just depends on what you. In this problem, I think it was easier if we just do 1, 1, and do a little Pythagorean triangle on there. But you know, if I gave you, well, not if I gave you. Let's say you had something like this, where this was like 1.2 square root of 3, and this was like -2 and square root of 5. Like, you know, you wind up doing the same calculation. But I think it might be harder if you have decimals and roots and things like that. All right, we are going to move on. All we've done so far is said, hey, look, if someone draws us a circle and gives us enough information, we should be able to come up with the center and the radius. Now, for all circles, if you want to know the equation of the circle, okay, so like you all know that if I do y equals mx plus b, you all know coming in here that this is a line. You all know that y equals ax squared plus bx plus c, that this is a parabola, right? So a line looks like a line, right? A parabola looks like this. But what's the equation of a circle? And remember, when you draw a circle is not a function. Why is a circle not a function? These two are functions. This is not.
It doesn't pass the vertical line test.
It doesn't pass the vertical line test. So all lines pass the vertical line test. Parabolas pass the vertical line test. Circles do not, because it hits more than once. Circles are not functions, but we can still have an equation for a circle. There still is some relationship between x and y that we can establish. And here it is. The standard form of the equation of a circle with radius r in center hk is this: x minus h, that quantity squared, plus y minus k, that quantity squared, plus r squared. You need to know this, all right? Now, if the center of the circle is at the origin, in other words, if a circle can be anywhere, right? A circle can be moved anywhere we want, right? And you can change the radius however you want. If you move the circle to the center, 0, 0, right there, okay? So that your center is at 0, 0, then in that case, the equation simplifies. So imagine that this h here is 0, and that k here is 0. So now all you have is x squared plus y squared is r squared. Do you see how that would be a little bit nicer version of a circle to look at? But that just means that your circle's at the center. And then the last kind of special circle you can have is one that's at the center and whose radius is 1. And this is called the almighty unit circle. And this unit circle, you will be beat over the head with this for the rest of the semester. This is the equation of the unit circle. So all that is this equation up here, replacing the h with 0, the k with 0, and the r here gets replaced with 1. And if you do that, you get this equation. All right? Any questions? We'll need this, as we go, you'll kind of get to see more of it, and hopefully it'll get locked in. Any questions? All right, let's do some examples. In the following problems, we want to write the standard form of the equation and the general form of the equation of each circle with the given radius. Hold on a second. I haven't told you general form yet, so let's just do standard form. We want just the standard form. All right, so who's up first? Caroline, did I call you? I don't think I did.
You haven't yet.
Yeah, you did respond earlier, but would you like to go ahead and go for this one? I'm going to copy this over here for you so that you have it.
Yeah, we're using the top equation or expression.
Well, you can always use this one. This is the most general form right here. So I'm just going to bring this one over.
Okay.
And slap that on there. Whoa. Move. Doesn't want to move. Okay, I'll put that one over here. All right, so everyone, Caroline's doing number 13. All right, so you know the radius and you know the center. So just plug into this equation. What do you got?
Parentheses x minus 0, right? And then squared plus y minus 0 squared equals 2 squared, which would just be 4.
Okay, and then now because those are zeros, can I just do x squared plus y squared equals 4? Is that okay? Everyone happy with that?
I don't know.
I'm sorry, Carolyn?
Like you could do, but that's what it looks like would be okay, but then what's the point of even having HK if there's going to be 0 in your...
Well, it's not always 0. Like some of these examples, the first 2 are zeros, but some of them are not.
Okay. So then, yeah, we can just do x squared plus y squared equals 4.
Yep. And that's it. We're done. All right. Next person gets number 15. So Lauren, you get number 15.
Yay.
Okay, what's this was number 13. So number 15, go ahead. What do you got?
I have x minus 0 squared plus y minus 2 squared equals 2.
2
squared.
Squared, okay. And then now the x minus 0 can become x squared. And the y minus 2, I can't simplify that. I mean I can, but that's the standard form right there.
I have a question.
Yes.
If you know that, like, if the problem says that the center is already at the origin, could you just use that other equation? Just like right there.
If it says it's at the origin 0, 0, then just use x squared plus y squared.
Okay.
Because you know it's going to turn into that. But I mean, just to start out here, first examples, I'm writing it all out. But yeah, I mean, absolutely. If you know it's at 0, 0, you can just go straight to x squared plus y squared.
Okay. Thank you, sir.
You're welcome. Okay, 17, the next one is going to go to Genesis. Well, hold on, Genesis, you know, I've called on you every class. Let me get someone who's only gone once. Yamna?
I have a question real quick.
Yeah.
So on number 15, the y minus 2 squared, why aren't we squaring that?
Because the standard form of the equation of a circle is always left in this form. Like you're leaving whatever's here, you're going to leave it to the, you know, squared. And then whatever's here, you leave squared. I think what you're asking is why aren't we expanding this out?
Yeah, like
multiplying
y
this out?
minus 4x plus 4 or something.
Yeah, that is actually called the general form, but I'm waiting on that. We're not doing that yet. This is the standard form. Okay, so who is up? Yamna? I'm calling on Yamna.
Yes, sir.
Okay, I thought someone asked me a question. How about number 17? Can we see it?
Yes.
Okay, so what is it going to be?
X minus 4 squared.
X minus 4 squared.
Plus y minus negative 3 squared.
Okay.
Equals 5 squared.
Okay. Okay, so this is the first, I don't know why this negative 3 didn't come out. Hold on. This is the first one where we actually have a negative number in here. So this is good, everyone. What Yamna said is right. We have the x, we take away 4, and then we have y minus negative 3. So my next line is going to be take that minus to a plus. There we go. See that, everyone? Minus is plus. This is minus. Okay, I think you all hopefully are catching on to this. So now I'm gonna reverse things on you. Okay, I'm gonna give you an equation in standard form, and I want you to tell me the center and the radius. All right. So I want you to find the center in the radius. Okay, and I'm going to give you 3 examples, and I'm going to let you work on these on your own. And then I will call on people. I'm going to give everyone about 5 minutes to do these.
Does that say 81?
That's 81.
Okay.
Give me a second here. I'll put those back up. Just give me a second. In case you get those first 3 done quickly, this last one is a thinking question. And if you think you can start working it, you can. But if not, just think about it. Okay, I'll give everyone 5 minutes. Let's make it 6 minutes. And if you need to take a little drink break or something or step away, you can. But we'll come back and talk about these in just a moment.
Okay, real quick.
Yep.
For B, is it just supposed to be y plus 7 or should it be?
Oh,
y
I forgot the
plus 7
square. Thank you. I apologize. This was squared. Is that what you're saying?
Okay.
Yeah, my fault.
Yeah,
Sorry.
I just want to double check.
Oh, thank you. I was incorrect there. We're gonna go one more minute. Okay. All right, so let's see. Genesis, I called on you or no? Oh, wait. No, I waited on you. Jackson. Jackson's up.
Hello.
How's it going, Jackson?
Good.
Okay, so how about the part A? Center radius?
For the center, it's 0, 0, and then the radius is 81.
Okay. Is 81?
Yeah.
Careful. Remember, this number here is always r squared.
So it'd be, would it be 9?
9. Good. So just be careful with that, everyone. All right. Jordan. Jordan here? I see
I'm
Jordan. Hey, Jordan, how about the part B? Center?
It would be 3, -7.
Good. 3, -7. Because it's a plus here, you have to put -7 here. Now, the radius is tricky.
It would be the square root of 3.
The square root of 3. Good. So look, everyone, the whole idea here is that the 3 here is actually your radius squared. So you have to take the square root on both sides to get what the radius is.
Oh, Professor, I actually found the square root of 3. I just put in a decimal point.
Okay, I mean, that's okay, but we want to try and leave things as fractions and roots unless we can get an exact, like if that were square root of 4, we'd put 2, of course. But if it's something that we can't do, then.
So just leave it a square root of 3. Okay.
Yep. Okay, good. Let's see. Next up is Michael Sayers. Mayers, sorry, Myers. Sorry about that.
Okay.
Okay, what do you got here?
For the center, be -1, 0.
-1, 0. Good. Radius?
2.
2. Good. Any questions there? Anyone? All right. Now, our lucky Samuel. Where's Samuel at? Samuel here?
Yes.
Okay. So I'm not expecting, Samuel, that you got D, but do you see why D is not the same as any of the others?
Yes.
Do you have any idea what we can maybe do?
I would say add the 4 to the right side.
We can move the 4 over. Okay. So Samuel, the thing that's different here, right? The thing that's different, we have x squared plus y squared, but we got these other things that have x and y in them, don't we? That's like the major difference here. So what we're looking at, and Samuel, I'll come back to you in a minute. What we're looking at here, everyone, is what we call the general form. What we've been doing is the standard form. So let me just show you real quick how you would go from general form to standard form. I'm sorry, from standard form to general form. Let's take this example right here. That's in standard form. And the reason it's in standard is because it looks like this up here, okay? General form all you do is multiply everything out. So you do x minus 3, you're going to have to square it. And then you do the y plus 7 times itself. And then equals 3. So I would FOIL this out. If I did that, I get x squared minus 6x plus 9. And then if I FOIL this one out, I get y squared plus 14y plus 49 equals 3. Any questions on what I've done there? Now what we'll do is we'll put, let's see, x squared here plus y squared. So I'm just going to be rearranging things. I put that and that together. And then I'm going to do the, let's do the minus 6x and the plus 14y. So minus 6x plus 14y. And then I'm going to get my numbers and put them together. So 9 plus 49 is what? 58? It's 58. So I get plus 58. And then equals 3. We're almost there. Almost there. Subtract 3, subtract 3. And what you get here is this. X squared plus y squared minus 6x plus 14y plus 55 equals 0. This is what we call the general form. Okay. So I'm going to show you a note here in a second that formalizes this, but do you all see now that this is in general form? Yes? Okay, so I was going to say in general, but I won't say general twice. So to summarize that idea, the general form of the equation of a circle is written x squared plus y squared plus some number in front of x plus some number in front of y plus some number equals 0. So if you went back and you did all these problems and you expanded them all out, then you would be in general form. If you leave them where they're in parentheses squared, that's standard form. So Samuel, this problem I gave you here is in general form. So the question is, how can we get it back to standard form? Because if we see it in standard form, it's easy to see the center and the radius. Do you all agree with that? If we have this form, where are you? If we have it in this form, it's easy to just visually see the radius and to see the center. But in general form, it's not easy to see what the center and the radius is. So I had asked Samuel earlier, right? Do you have any idea? So Samuel, I'm going to stick with you. Samuel, if I were to rearrange this, put my x's together next to each other, put my y's together, and you said move the 4 to the other side, which I'm happy to do. I'm going to add 4 to both sides. Then Samuel, thinking about what we started class with, focus all of your attention on this right here. What do you think we could do to that in order to make it turn into like something squared? What did we do earlier?
Factor it.
Remember our 2 preliminary concepts, distance formula and this. Complete the square. I mean, I covered this earlier because obviously it was going to come up again, right? Well, it's here now. So Samuel, we are going to complete the square on just the yellow part first. All right. So I'm going to do it on the side, Samuel. Okay, Samuel, when I do this for completing the square, I must have a 1 in front of the x squared. I have a 1, yes?
Yes.
Okay, so now I look at the number in front of the x, which is -2. And what do I do with that number, Samuel?
You divide it by 2.
Okay, so I'll take -2 divided by 2. That gives me -1. That's my first magic number. Now I take that number and square it. -1 squared gives me 1. That's my second magic number. And Samuel, what do I do with that second magic number?
You add,
Mhm.
and it's so it could be 0.
Right, like that. These first three, Samuel, will turn into something squared. What?
It will turn into
It'll always be X, and then the thing that goes here will always be that number.
yes.
-1 squared. That takes care of the first three. Samuel, what do I still have out here?
-1.
-1. Okay, you're off the hook. Good. Does everyone see that? Everything that's in yellow on the left can be rewritten like this. All right, my next volunteer is Cameron Salinas.
Yes, sir.
Okay, so Cameron, any idea what we're gonna do now?
You would do the same thing for the y?
Exactly. We're gonna do the y's, and we're gonna do completing of the square of the y's on the side, and then we'll go and paste that back in. So you actually have to complete the square twice in this problem, 2 different completings of the square. All right, good job. Cameron, do you want to keep going?
Yeah, I can keep going.
Okay, so what now?
You would take the -4 and divide it by 2.
Mm-hmm.
So then you get -2. And then you would square that.
Square that.
Mm-hmm.
4.
And then you would do y squared minus 4y plus 4 minus 4.
Okay. Those 3 become?
X minus 2 squared.
Close. You said X though.
Oh, y, my bad.
Okay,
Y.
to just make sure everyone, because that's a common habit that people will do. They're like, I'm completing the square. I always put X, but here are variables Y. So y minus 2 squared and then -4, right?
Yes, that's correct.
Good. Okay, you're off the hook. There it is. So now the next step, Joshua. Are you there?
Yeah, sorry.
Okay, so I just want to rewrite the whole thing, right? So I'm going to rewrite that, rewrite that, rewrite that. So go ahead.
So it's going to be X minus 1 squared minus 1 plus y minus 2 squared minus 4
equals 4, right? Because
4.
we want to just bring this equation down. Okay, Joshua, any idea what I could do next?
Could add 5.
Yeah, so this over here, these two together really mean -5 on this side. So I'm going to add 5 to both sides of the equation. And that will take us to our final line. Any questions on that?
So would R be 3 then?
Yeah, so radius is 3. Go ahead, Joshua. The radius is 3. What's the center?
The center is 1, 2.
1, 2. Perfect. See, now we've got it in standard form. You can get the center real quick. 1, 2. Radius is the square root of that, which is 3. And we're done. What do you think?
Good. I tried to factor it and I got the center, but then I got stuck trying to find R by doing FOIL.
Gotcha. Okay. This concludes the topics for today. We've covered everything. So now it's just a matter of, can I throw some of these at you and see if you do them? So here's what we're gonna do. We still got about 15 minutes. I'm going to assign, let's see, which one did we just do? Did we do this one? We did that one, right? We did 29. So here's what I'd like for you to do. Copy down number 30 and copy down number 31. I'll give you a minute and a half to copy those down. And then I'm going to break you all out into breakout rooms. And I want you all to complete those in the breakout rooms together. Try and talk to one another, you know, just be like, yeah, this is what I'm gonna do, or, you know, and then you can work on your own and then check your answers with your group. But I will pull everyone back into this session, I don't know, right before class ends. I'll pull everyone back here and we'll just kind of see, I'll call on a group and see if you can tell me what the center and the radius are for each of those. Oh, and by the way, skip the intercepts. Don't worry about finding the intercepts.
Okay, real quick.
And when you do your homework, if it asks for intercepts, just skip it. I realize you'll get it wrong, but just skip it. I'll talk about intercepts next class. It'll take us 5 minutes.
Okay, you said 30 and 31 or 32?
30 and 31.
Okay.
All right, I'm gonna go ahead and make the breakout rooms now. And I think, what do you think? 3 people, 4 people? How many people you want in there? What do you think is better, 3 or 4?
Four, so you can do an X and Y of each problem,
4.
X and Y side of each problem.
Okay, it's going to create randomly 6 breakout rooms with 3 to 4 people in each one. All right, so you'll be invited, and go ahead and go in there, and we'll all come back here in the next like 12 minutes. I'll pull everyone back. Enjoy.